Hello everyone. To begin Tier 3, we're going to be discussing Unit 13, which is factoring. Do know that this is going to be a long video because factoring is a very important part of pre-calculus algebra. So if you do plan to go on and take Math 171, this key topic right here is going to play a role in pretty much everything you do in that course. So please make sure that you're paying attention and taking good notes. And then if you have any questions, of course, you can contact me. The most basic form of factoring is taking out what we call the greatest common factor, or GCF. The GCF is the highest number that divides exactly into two or more numbers. So it says if you can't determine the GCF, you can always list the prime factors and then multiply those factors together that they have in common. If there's no common prime factors, then the GCF is 1. Now, I will tell you, if you have a graphing calculator, your graphing calculator will find the GCF for you. If you hit the math key and then you scroll over to num, N-U-M, and then you scroll down and find GCF, or sometimes it's called GCD, you can put in the two numbers that you have and then hit enter. Make sure you close the parentheses and hit enter, and then it'll find the GCF for you. So let's look at some examples. Again, think about what GCF means. It is the highest number that would go into both 4 and 12. Well, 2 goes into 4 and 2 goes into 12, but it's not the highest number. 4 will go into 4 and 4 will go into 12. So the GCF here is going to be, GCF is going to be 12. Here, again, sometimes it's really hard to look at these numbers and determine what would go into 42 and 90. Again, we're looking for the highest number here. Again, this is probably a part where I would use your calculator and come up with what would be the highest number. Another option is, this is kind of the long way, is breaking these down into prime factors. So this is using a factor tree. So 3, 2, and 7 would be your prime factors here. We could do 9 and 10, break it down into 3 and 3. And then 2 and 5. And then what you do is you look and you multiply the common factors that they have together. So notice 3 and 2 here, and there's a 3 and 2 here. So 3 times 2 would give me a GCF of 6. Now what about variables? It says the GCF for variables will be the variable with the lowest exponent. So which one of these would go into each other evenly? It would be the lowest one. So a squared will go into a squared, and a squared will go into a to the 5th. So a squared would be my GCF here. If you have multiple variables, you look at each variable individually. So m, the lowest one, is going to be m to the 3rd. N, the lowest one, is going to be n to the 4th. So let's put all this together. So find the GCF of the following. So what's the number, the highest number that will go into 15 and 35? That's going to be 5. And then my lowest exponent here is going to be n squared. So 5n squared is my GCF of both of these. 24 and 32, what is the highest number that will go into 24 and 32? And that's going to be 8. And then variable-wise, we can say x to the 3rd. And then my y's, you got an 8, and then this is technically a 1, so just y would be my variable for my y. So why are we doing this? The purpose is to factor out a GCF. Again, this is the most basic type of factoring, and this is the factoring that you always want to look for first when you're given a problem. Now, before in this class, we've been multiplying. So we've been taking the number that's outside the parentheses and multiplying it by each number inside. This is the distributive property. Factoring is the opposite of the distributive property. So basically that number outside the parentheses is your GCF, which is what you're looking for. So you bring that number out of the parentheses and then you write what's left in order to get back to the original problem. Notice the original problem and what you get with your factoring, it should be the exact same. These two are equivalent to each other. This way you can always check your answer to make sure you're on the right track. So let's look at the steps here. First, find the GCF. So let's look at this example. What's the number that will go into both 8 and 6? The highest number would be 2. Variable-wise, we got an x squared and an x, so the lowest exponent would just be x. So there's my GCF. It says we want to write that GCF on the left-hand side of a set of parentheses. So we take out 2x and we draw a parentheses. And then it says divide each term from the original expression by the GCF. Essentially, it's the opposite of taking 2x and multiplying it. Here's the question I like to ask myself. 2x times what is going to bring me back to 8x squared? Well, 2 times 4 is what would give me 8. And then x times what would give me x squared? Well, x times itself, x times x gives me x squared. I'm going to keep this sign the same as it was in the original problem. And then 2 times 3 is what gets me back to 6. Now, would you want to put any variables over here? Think about it. You're trying to get back to 6x. Well, 2x times 3 gives me 6x. So I don't want to put a variable here, or I'd end up getting x squared or x to the third or whatever the case may be. That's it. So again, you could always check your answer because you can mentally just take 2x and distribute it back out, and it should bring me back to this right here. Let's look at some more examples. The highest number that will go into 14 and 7 would be 7. Look at my variables. I'm at x squared would be my lowest x. Y would be my lowest y. So this is my GCF. I'm going to draw my parentheses here. Now 7 times 2 gets me back to 14. What you got an x squared here. It's really like, well, it's almost like addition, because think about when you multiply variables, you end up adding them anyway. If you got x squared, how many more x's do you need here to get back to x to the third? Well, I only need one more. I've already got a y here. I don't want to put another y because that would give me like a y squared. So I'm not going to put any y's because 7x squared y times 2x is what would bring me back to this guy here. Now, if you wanted to put a 1 here, you could. Technically, you don't need to. You don't need any x squareds because x squared, you already got one here, so you don't want to multiply it by anything. But look, you've got one y, and you're trying to get back to y to the fourth. So what do you need here? You need 3 more y's in order so that y times y to the third would get me back to y to the fourth. Let's look at an example with 3 terms. 24, 16, and 8. What's the largest number that would go into all 3? That would be 8. My x's, you have to look at all 3 terms here. This is a 5, 2, and a 1, so just 1. The y's, it's a 3, 1, and a 1, so the lowest exponent would be 1. I'm going to draw a little larger set of parentheses here. 8 times 3 gives me 24. X to the fourth, so I would need 4 more x's to get back to x to the fifth. So x times x to the fourth gives me x to the fifth. If I've got one y and I'm trying to get to y to the third, I need y squared plus 8 times 2 gives me 16. And I've got an x, I'm trying to get x squared, so I need one more here. I've already got this y, there's a y there, I don't need any more y's. Now, this part kind of gets students. It's like, well, I've got an 8xy, I've got 8xy here, so I don't need to put anything. Well, if you don't put anything, it doesn't exist. So if I just drew my parenthesis here, then this last term wouldn't exist. This is a case where you have to put a minus 1 here in order to do 8xy times negative 1 is what would bring you back to negative 8xy. I want you to pause the video at this point and try some factoring using GCF on your own, and when you're ready, hit play to check your answer. So this first one, what we can do is take out a 3 because that's the largest number that would go into all 3 of these, and then in terms of your variables, you can only just take out an x. So what's going to get me back to 6x to the third? It would be 2x squared. What would bring me back here would be minus 3x. And then plus 3x times 4 is what's going to get me back to 12x. And then this one down here, 7, would be my GCF. Variable-wise, an x and then a y. So I'm going to multiply this by 2. I need 2 more x's, so x squared. I don't need any y's. You can put a 1 if you want to, but really the only thing you need to go from here to here is 1 more x. And then you do have to put a minus 1 here in order to have this term exist. All right, so let's take a look at one that some students are like, well, I don't know what to do at this point. Now, if you look at both of these, there's no number that would go into 6 and 7 other than 1. They don't have any variables in common, so you can't take out a variable. If you can't take anything out of these, and there's no other way of factoring that we talk about in this video that you can do, then you always have the option of putting prime. Prime means that this cannot be factored down any further, so essentially that you're done. Now, let's look at a case where you can factor out a polynomial as the GCF. So this sounds a lot more confusing than what it is. So this is 6 times x plus 2 minus y times x plus 2. Think about what GCF means. GCF means greatest common factor. So what does this term and this term have in common? Well, they don't have any like numbers in common per se, but they do have a term in common. So notice they both have an x plus 2. So what that means is, well, let me factor out the x plus 2 as my GCF. So it's basically the same steps I talked about a while ago. I'm going to write this GCF first, and then I'm going to draw my set of parentheses. Well, what is x plus 2 being multiplied to get back to here? Well, it's being multiplied by 6, so I'll put 6. What is x plus 2 being multiplied by here? Well, it's being multiplied by minus y, or negative y. So I can rewrite this as x plus 2 times 6 minus y. Let's take a look at this one. The GCF is going to be x squared plus 2. What is that being multiplied by? It's being multiplied by y here, and it's being multiplied by 3 here, so y plus 3. Now let's take a look at this one. My GCF is going to be y plus 1. What is y plus 1 being multiplied by? Well, it's being multiplied by x minus y here, or excuse me, xy here. And then this, again, is one of those situations where it's like, well, I don't have to put anything because there's nothing outside this parenthesis. Think about what's really outside this parenthesis here. It's really a minus 1. So if you don't see anything written outside the parentheses, you can always put a 1 there as a placeholder.